Hi there, my name's Jackie Decker. This is an intro to solving equations using algebra tiles. Throughout this type of a lesson, you want to just give a problem to students, give them some quiet think time, then some collaboration time to allow that productive struggle to happen. And as they manipulate their tiles, you want to notice and name the math they're using. Oh, I notice you're dividing those into equal groups. Oh, I notice that you are creating some zero pairs. This is where the learning happens deeply. You want to think about the sequence of problems that you're going to give to students to allow that to happen. You might want to begin with a problem like 2x equals 6.
So if you've given your students the problem 2x minus 6, you might want to have them set it up on a board where we've split the two sides of our equation, because we're going to talk to students a lot about equivalence. We want this side to be equivalent to this side. We might draw that or think about that as a balance. And first we just start by asking students to represent that. And so our students have had lots of practice at representing different polynomials. So they're going to show us these are 1x tile, 2x tiles. Here I've got 2, 4, 6 tiles. And then we're going to ask them, what's that unknown? We know this x is unknown. We don't know how big it is. It's different sizes and different contexts and different problems. And students will experience a little bit of productive struggle. And then they're going to say, well, if I equally divide these tiles, I'm going to find that each of these x's is worth 3. And I'm going to say that x equals 3. So after we have had students do a lot of problems with only the tiles, we do want to start helping them see the connection between the concrete and visual model and the algebraic way that we use in class sometimes. And so once our students have said, well, I'm going to divide out those x's, I'm going to equally divide these tiles into two groups, we might show them that algebraically that might look like us saying, well, I'm going to divide this side by 2, and that gives me a single x. But I know that I have a balance here, and whatever I do on the left, I do on the right because of that equivalence. And so if I'm dividing one into two equal groups, I'm dividing the other side into two equal groups. And that's where I see that x equals 3. And I might highlight for them where we see it with the tiles so that they understand why we do what we do with the algebra.
Give students lots of practice with one-step equations. Here is 3x equals 12. Students showed that division into three groups in lots of different ways. Here's another way, and here's a third way. You want to put some thought into what you're going to ask students to solve next in your sequence. You may want to stick with one-step equations, like x plus 1 is equal to 5. Or you might want to move straight to two-step equations. I've seen a lot of success with students when they are challenged by a problem like this.
So when we choose to give students this equation next, we do observe some productive struggle, which is great. That's where the learning happens. That's where our brains are growing the most. But students will look at this and think, I don't know how to divide this into equal groups the same way I was before. I know I want 1x by itself, but I have this extra 1. And so students will think about that. Some students will immediately take out the 1 and say these are equivalent to each other. And so the rest of these needed to be divided into two groups. Other students will start off by trying to divide those into the three groups and recognize then that 1 and 1 are equivalent. So these two only need to go into the groups, with the x showing us that x is equal to 2. So once students have practiced a lot of those two-step equations with their tiles, we do want them to see the connection between the concrete and the algebraic. And what they have done when they have recognized that this one and this one are equivalent to each other, and we don't need to consider it, we can consider that we're now removing that from the equation. So when we show students that we're subtracting 1 from both sides of that equivalent equation, that's what we're doing. We are removing those ones from each side. We're thinking about subtraction as removal. Now we only need to worry about the fact that we now have 2x being equal to 4. And this is when students are dividing that into two equal groups. They're seeing one group here, another group here, and that's where they're showing us that they've divided into two groups, and we now see that 1x is equal to 2, which we see right here.
Be sure to give students lots of practice with two-step equations like this one, where we are showing the answer on the left and the question on the right. This is really important to build the idea of equivalence. And here's an example of what students did with that. And then next in your sequence, you might want to move into problems that involve negative numbers to really make sure we bring out that strategy of using zero pairs.
So when we give students a problem that looks like this, x subtract 2 is equal to 6, they can represent that, but then students are unable to use the strategies they've been using so far. We can't divide this x into groups, we only have one anyway, but we have this extra negative 2. And with some productive struggle and some quiet think time, some time to talk to each other, some students will remember what they know about zero pairs, and they'll create a zero pair by adding positive 2 to this side. But they remember that importance of equivalence and balance, and so they also need to add positive 2 to this side. We have a zero pair here and a zero pair here, and we are left with only x on this side and with 8 tiles, showing us that x is equal to 8. So after students have had lots of chances to do lots of problems with only the tiles, we now want to connect that to the algebraic model. And so when students added a positive 2 here to create 2 zero pairs, and they added positive 2 on the other side to keep equivalence true and to keep that balance, to make the zero pairs over here, we're going to represent that algebraically as adding positive 2 to this side and positive 2 to this side. We want to be really careful with our language here, and we want to say, even if we use annotation like this, we don't want to say cancel out, because that might mean add to 0, but it also might mean divide out to 1. So we want to talk about adding to 0 or making 0 pairs, and that leaves us with that x is equal to 8, which we see over here. We've got our x equaling 8.
After going through a logical sequence, give students lots of practice with lots of different equations to solve, and make sure you spend some time then moving from the concrete to the algebraic and helping students see the connections between them. Thanks for listening.